Hey, my name's Dave Fisher. Thank you for watching the Lost Creek Elementary School grant application. I just think videos are a great way to introduce things. So I watched the YouTube video and read the RFP for this grant, and the video I thought just helped a lot. So it inspired me to make a video for the application. This application is for the Lost Creek Elementary School Library. Lost Creek is an elementary school for pre-K through 5. They've got about 650 students. And they're located in Terre Haute, Indiana, situated right here. You can see an aerial view of their building. Now, interestingly, across the street and down just a little is Rolls-Holman Institute of Technology. I'm a faculty member at Rolls-Holman Institute of Technology. I'm in the computer science department, and I've been volunteering for the library for a while now, and I wanted to help them get this grant application together. This whole thing started last year, actually, when Lost Creek started a MakerSpace library club. This is a club that meets after school. They've got about 150 people total if you add up all their days. It was led by Monica Zimmerman, who's in charge of the library and the media centers there at Lost Creek. And this MakerSpace, it gets kids hands-on building things. So some kids use Legos, some kids make flubber, other people work with building things and just creating things. In that space is also the computer labs. And in the computer labs, there have been some faculty and students from Rolls-Holman that have helped with computational thinking. We've done some things with WeDo in the past that have been successful. And so what we wanted to do is we wanted to grow that program, so grow our library club, and also make some opportunities for the rest of the school as well. And it works out really well for this grant because the goal is to make modules for Ready to Code initiatives, and that's just what we're wanting to do for this program as well. The modules that we would like to make for the Ready to Code initiative are things for hands-on robots and other microcontrollers. We found that hands-on really helps engage the kids, and it's something we're really good at. And it's something we wanted to give to the MakerSpace Club at Lost Creek and also to be part of this cohort. So we're really excited about the potential here. We've picked 2 robots. There's a lot in the educational robotic space. The first one we've picked is called the Microbit. So the Microbit is a microcontroller that started in the UK. They gave one to all of their 11-year-olds. It's just a tremendous platform. I'll show some more about that one. And then the other one is the Lego Boost. So here's a Lego Boost sitting right here. And it's Lego's next initiative. They've done 3 generations of Mindstorm, 2 generations of Lego WeDo, and Boost is their current product. And we think that it's a really good fit with what we're doing in our Maker Club, and we think it could be a good fit for like other schools that want to make Maker Clubs, and even public libraries. So the Microbit, just to kind of start with it more, what we're hoping to do is we're hoping to use the Microbit in the club, obviously, but we also want to roll things out to the rest of the school. So if there's 150 kids in the Maker Club, maybe a third of those are regular with us in the computer lab, 50 people, right? And we would like to reach the other 650 that are at Lost Creek. And so we want to make some modules that teachers can teach and work with in their computer lab time. An example of how Microbit works, there's a program here. This shows a check mark when it starts. And then if you press the A button, it just says a really simple hello. It's a block-based programming tool. There's a lot of things you can do with it. You can also program it in Python as well if you'd like. In addition to buying the Microbit board, which you saw there, you can also get it on robots, right? So this is that same Microbit board. It's just kind of plugged into a robot chassis now. And you can do things like what we show in this video, which is to use the sensors on the front here to detect light and dark values. And then from that, make a control decision about how to keep it on the line. And it's a classic problem for line following. And it works out well because it has you think about the sensor values, how you want to make an algorithm to solve that problem, and then how you want to tweak that algorithm to try to make it get around the track as fast as you can. The other robot that we're looking at is the Lego Boost. So the Lego Boost, I guess I can kind of show it here. He is programmed with an iPad app, which can be a lot of fun. It's also a block-based programming language. And the idea of Boost is that it's really good for our Maker Club because there's things that you can build with it. Obviously, there are built-in like 5 or 6 robots, but we're more interested in things you can do that are creatively independent than that. But even during the regular exercises, which we do, here's kind of an example of one. So this is a challenge to try to get it to go around a maze and shoot a target. And here I've made a little video about this. But the idea here is that you need to figure out how to break this problem down into pieces to kind of do the early navigation and then turn and shoot. And if you want to have a little victory dance afterwards, that's fine with us as well. But these two robots present a great opportunity to help students like get excited about computational thinking. These are actually strategies that we've used at Rolls-Holman for a while, which is why we're excited to be volunteering with Lost Creek. So at Rolls-Holman, we've done things like a summer programming camp called Connecting with Code that's been very successful. You can see some of our students using microbits in our summer programming camp. We've also done things in our college classes. So here you can see it's a fleet of Lego Mindstorms. So this is the 3rd generation Lego Mindstorm. And we've been programming those with Python in our intro programming classes. And we love to bring these opportunities to other places. So yesterday, actually, we were in Indianapolis at Ignite Your Superpower. It was 600 middle school girls, so girls only invited. And if you look closely at this picture, you can see our Lego Boost in there. You can see our microbit robot in there as well. And we're really excited about these opportunities, and we have a lot of experience in these things. I love that the grant is looking for inexperienced people and also some of the more experienced. We're the higher end of the spectrum, and we'd love to work with some of the people that are just getting going. We just really would love to be a part of this cohort. The other part of our proposal that you'll see is that we're trying to do some more things with incentive programs. We think people would do these modules no matter what, but you get more people to do it if you incentivize it a little bit. So for example, we'd like to do teacher training. So we've got in the grant opportunities to pay teachers for some after-school education modules, and then they would be able to use that information inside their computer time. We also want to motivate the kids to take part of it. So we've got rewards once they meet certain criteria to have a party for their rooms, or for example, a pizza party. So that's what we would like to do if we were accepted for this proposal. We think we'd make really good use of the funds. Our primary use of funds would be, of course, the robots and then the Lego robots. For our funds, we'd also need some iPads. A lot of schools already have iPads, and so I think that at the $160 price point, this is a great robot, especially if you already have iPads. Obviously, if you don't have iPads, that's a very expensive proposition, but a lot of public schools and school systems have access to iPads they can use. And we think that our modules that we can make would make a really good addition to the Ready to Code toolkit. So we hope to join you. Thanks.